Okay, when you add or subtract scientific notation, you just need to remember that the powers of 10 have to be the same, and when they are, then all you got to do is either add or subtract the numbers that come with the powers of 10 or in front of the powers of 10. So in this case, 1.2 times 10 to the third minus 1.0 times 10 to the third. The powers of 10 are exactly the same, so all you got to do is just pretend like these powers of 10 are x's. And what would you do if they were just x's? You would just subtract these two numbers and be done. But I have added a twist, and so when we do this, we're going to get 1.2 minus 1, which is 0.2, and then we just add the times 10 to the third. We treat it just like a variable. However, this is not proper scientific notation. So in order to make this proper scientific notation, I want to break this 0.2 down and make it what would be proper scientific notation, which is one significant figure in front of the decimal times 10 to some power that would get me this 0.2 back. 2 times what power of 10 is equal to 0.2. Well, that would mean moving the decimal back to the left one place to get back to 0.2, so it would be 10 to the negative 1. So once I've done that, now I can bring this times 10 to the 3 down and recombine my powers of 10, and that would give me 2 times 10 to the negative 1 plus 3. Why would it be plus 3? Because when you multiply powers of 10, you add the exponents. So that would be 2 times 10 to the second power. Okay? So that's one problem worked, and that one was relatively simple because the powers of 10 were already a match for each other. Down here, the powers of 10 are not already a match for each other. So, as I've suggested before, it might be a good time for you to pause the video, figure out how you would work this out, and then play the video and see how I do it. All right, so what I'm going to do first is I'm going to ask, are these powers of 10 already the same? No. Since I'm adding, they need to be the same so that I can proceed. So how do I get them to be the same? And here's where the trick comes in with this stuff. You always want to raise the lower power. Okay, keep that in mind. You always want to raise the lower power. And so in this case, what I'm going to do is I'm going to raise up 10 to the fourth to make it a match for 10 to the sixth. Now, how do I raise up 10 to the fourth to make it a match for 10 to the sixth? I'm going to multiply 10 to the fourth times 10 to the second, and that's going to make me have 10 to the sixth right here. But if I just do that, then I'm changing what this number means. Right now, this number means 88,000. If I multiply it times 10 to the second, then it's going to mean something else. It's going to mean 8,800,000. So I want to keep it as meaning 88,000, but I want it to look like something times 10 to the sixth power. So here's how I do it. If I want to raise this up by multiplying times 10 to the second power, then I'm going to keep things the way they are by also dividing this by 10 to the second power. So times 10 to the second power here and divided by 10 to the second power here basically cancel each other out. They just would, as a fraction, equal 1. And so I'm really not changing the value of all this. I'm just changing the way it looks. And that's exactly what I want to do. So I'm going to rewrite this as 10 to the fourth power times 10 to the second power is 10 to the sixth power. And 8.8 divided by 10 to the second power means I'm going to move that decimal 2 places to the left. So that's going to be 0.088 times 10 to the sixth. That should be the same as 8.8 times 10 to the fourth. I could put it in my calculator and find out. But for right now, I'm just going to trust myself because I think I know what I'm doing. Okay, so now I still need to add this to 5.4 times 10 to the sixth. I haven't done that yet. So now that I've gotten the exponents to be the same on the tens, all I got to do is add the 5.4 and the 0.088, and that's going to be 5.488. If I lined it all up, 5.4088, just like we learned in elementary school, just add the place values. Okay. So then the power of 10 stays the same, just like an exponent. Just like a variable. And this is my final answer. Let's try this one. Same kind of problem, except here we have subtraction instead of addition. All right, so let's get to it. These two powers of 10 don't match. I'm trying to subtract, and so I'm going to have to make them match so I can subtract them. So which one do I want to raise? Always raise the lower one. Remember, 10 to the 7th is lower than 10 to the 9th, so I want to raise it up. I multiply it times whatever the difference is between 9 and 7 times 10 to the 2nd power. That will raise it up to 10 to the 9th. Now, multiplying times 10 to the 2nd, I want to make sure that I basically negate that action over here by dividing by 10 to the 2nd. This divide by 10 to the 2nd and this multiply times 10 to the 2nd will neutralize each other's effect because I want to keep the value of this the same. So now I have times 10 to the 9th over here. 7 plus 2 is 9. And this divide by 10 to the 2nd is going to move this 2 places to the left, the decimal, because it's power of 2 on the 10. So now I have 0.021 times 10 to the 9th. And I'm still subtracting 6.8 times 10 to the 9th minus 0.021 times 10 to the 9th. Since the powers of 10 are the same, all I got to do is subtract the two other numbers, 6.8 minus 0.021. I'm having a hard time doing this in my head. So that's going to be 9, that's going to be 7, that's going to be 7, that's going to be 6, I think. So, yeah, that looks right. So it's going to be 6.779 times what? Since there's subtraction, you just keep these two powers the same and bring it down. So this is our final answer on that. I wanted to give you one where you had to recombine the powers of 10 like we did up here, but I messed up my example problems and I'm not going to do another one. I hope this has been enough. I hope it helps. You will have a quiz on these powers of 10, adding, subtracting, multiplying, and dividing every day in class until everybody seems to get it.